Thank you, thank you. Hi, everybody. I'm really glad to be here again at Scala Days and presenting one of my favorite technologies, Akka. I just spoke with the Akka team and they told me Akka is like the new JBoss for Scala or something. Not sure. We need to discuss that. Who of you has already used Akka? Oh, awesome. All right. So I don't have to explain all the basic details. That's awesome. So I'm going to talk about something I really love about Akka. It's called Akka Typed. It's a new module. And before I dive into the details, let's take a step back or go a step back and look at the essence of Akka, the actor. So what is an actor? That's one of my favorite actors or dudes. But the foundation on top of which Akka is built is the actor model, which has been invented in the 70s by Carl Hewitt and others. And they defined the actor as a fundamental unit of computation. So that essentially means actors are the building blocks for your program. And actors embody processing, storage, and communication. Processing essentially means they can do stuff. And storage doesn't mean disk storage or something like that, but it means they can have state. And I think this is really the essence of factors, that they are meant to have non-local, potentially distributed state. And they do communicate using asynchronous messaging. And it's important to understand that one actor is no actor. They come in a system. So in order for actors to collaborate, they need to know each other, or they need to know their addresses so they can communicate, okay? I think that's pretty clear. And now, let's talk about the do stuff. And in Akka, that's called a behavior. So the behavior is what defines how an actor handles messages. The behavior, according to the actor model, is very lean. So an actor can only do a couple of things. So it can create new actors. It can send messages to known actors. So that means it has to know the addresses of the other actors. Maybe they arrived via messages. Maybe the actor has been created with that knowledge already. And this is really important, an actor can change its behavior, or it can designate the behavior for handling the next message. And while that might sound a little weak, it's actually really strong. Because if you think about this behavior, which can be changed, that really means that you can encapsulate state here, okay? And we will see that in detail how it's implemented in Akka. All right. So we have Akka untyped, the good old Akka untyped, and we have Akka typed, the brand new one. So let's take a look at how they implement the actor model. Here is a protocol. The message protocol is like the API of an actor, because actors from the outside cannot be, or you cannot call a method on an actor from the outside. You even don't ever get a reference, an object reference to your actor. All you get is the address. It's called actorref, and you can send messages to it. So the messages really define, so to say, the API, what you can do with that actor. Here's an example, an account. We can get the balance. So that's a message we send to the actor. Let's refer to these messages as commands. And you get a reply balance. And you can deposit some amount and get back and acknowledge deposited. And with withdraw, it's a little more interesting, because maybe your bank does not give you money if your balance is negative. So you could get a reply insufficient balance, or you could get a withdrawn. All right, that's the protocol. And the implementation in Akka untyped could look like this. That would be a very idiomatic Akka untyped implementation. You have an actor trait you have to extend from, and you use a var. As I said, act is really meant to keep and encapsulate state, and using a var is what most people do with Akka untyped. And here's the receive method that defines a partial function from any to unit. What do you think about that signature? Awesome! Yeah, it's a very, very flexible signature. Yeah, you can do anything, and you get, well, it's called unit, but you get nothing. So essentially, Akka untyped is really untyped. Or unityped, I don't know. So the receive defines the behavior. An actor really can receive any message and then does something. So here, when getting the balance, we have this nice implicit sender. So this actor knows whether there was some other actor who sent a message to it, and it can then reply. And here we reply with a balance, and with deposit, we would just mutate the var, and so on. I think that should be pretty clear. By the way, if you have questions, let me know anytime, okay? So that's a typical implementation. You could also do a slightly different implementation, which is changing the behavior of an actor. So the receive method that defines the initial behavior goes to this method and initializes the account with an initial balance, as you can see here. And then when we deposit, we change the behavior. So instead of using a var, we change the behavior. And that's totally possible in Akka untyped. Who of you has already used that context become? Okay, that's about half of you, probably for state machines or things like that. And yeah, so that already looks a little bit or pretty close to the original definition of the actor model. All right, so now let's take a look at Akka typed. And there's a couple of important API changes. First of all, because of being typed, your actor ref, your actor address is typed. So having an actor ref of T means you can only send messages of type T to that actor. Please don't use any as an argument. Then you're back in good old untyped. And there's no more actor trait you can extend from, but instead you have to define a behavior of T. So that's also typed. And as a consequence of that, there's no more implicit sender. Think about that. Why is there no implicit sender? What type should it be? Actor ref of what? Any, potentially, or nothing. But this is a runtime aspect, and the compiler would not know. Okay? So there cannot be an implicit sender anymore. And also there cannot be an actor selection. So that means that we have to, so whenever we want to implement a protocol, let me move back here, where we have like this request reply pattern, a command and a reply, we need to change something, okay? Because we don't have this nice implicit sender. All right. This behavior of T looks a lot like, in a simplified version, a function from a message to the next behavior. And that really nicely matches the original definition, right? An actor can designate the next behavior. So whenever an actor receives a message, it has to tell Akka the next behavior. And these messages are either of type T, or they can be special Akka messages called signals, like terminated, if you watch some other actor, or post stop pre-restart. And in order to create a behavior, you go to this behaviors object, and that contains a couple of factories like receive message or same, and we will take a look at that. Okay, so this is again the protocol for a, well, that's the untyped protocol. And what do we have to do to make that work in the typed setting? What do you think? Who has an idea? Yeah. Okay, I think I didn't fully understand. You mentioned a trait for what exactly? Aha, for the messages that are incoming, yeah, that might be a good idea because we need to define some type for the T. Okay, great. So we need to define a trait, maybe even a sealed trait for the commands, for the incoming messages. What else? How can we make our typed actor reply? Yes?
Basically a link for the sender, including the message.
Exactly. Yes, so we have to include the reply to address. So whenever we want to be able, or whenever we want our actor to be able to reply, this actorref to be replied to needs to be included in the command, in the message that is sent to the actor. So that's more work for us to do, right? But on the other hand, it makes the whole thing more explicit. Then you can even see in your protocol that this is a request reply protocol and not just a fire and forget single way. So let's implement a typed actor. Let's do some live coding. Please help me if I get lost. Okay, I think you can read that, right? I'm going to the account, the typed account, sorry. So the first thing we need to do is define this command trait. Let's use a sealed trait. Command is a great name, in my opinion, especially if you go for CQRS or something. So our incoming messages need to extend command. Okay, cool. And now we can define the behavior. I'm using the apply method here to define or return a behavior of command. All right. Then the other thing you already mentioned is the reply to. So we no longer can use a case object because we need to include, that's too many S's, yeah, thank you. We need a reply to, and now actorref is typed. And what type should I put here? Any ideas? Balance, exactly, because we want to send back the balance. Great. Okay, cool. That's the one thing here. For deposit, that's also pretty straightforward. We need this type. Well, the type here is, comma's missing, sorry. Deposited.type. Looks a little ugly, but okay. And then finally, here, we also need a reply to, reply to of type actorref of something. But here it gets a little nasty. So what should we put in here? Insufficient balance or withdrawn? Yeah, exactly. Let's make a trait. Yeah, we could also use an option, but what if, or an either, but what if we have like 3 potential outcomes? So I prefer to use ADTs for that, sealed traits. So let's call that withdraw reply. It's a little hard to type on this. Yeah, anyway, withdraw reply. So we can then use that and extends withdraw reply and extends withdraw reply. Okay, that's the protocol. Whew. Mission achieved, almost. So now we also have to implement the behavior. So for the behavior, as I said, we can use the behaviors object, which has a couple of nice factories. We can be lazy and just do that, but that would not serve its purpose. So when we don't need any actor context, and we don't need it here because the actor context is also, like in Akka, untyped used to create child actors and stuff. We don't worry about that right now. We can use this receive message that just takes a function from T to behavior of T. And we can use a nice pattern matching, get balance, and reply to. And then we can say reply to, bang, balance. And that is our balance. The balance is given as a parameter to the apply method. But the compiler is not happy because we have not yet designated the next behavior. Which behavior should we now return? Exactly, because we don't change any state, okay? So our behavior can be the same, and Akka internally optimizes that, so it doesn't really have to switch the behavior, it just keeps the same behavior. So that's the meaning of this special behavior. Okay, so let's also quickly do the deposit, and then I can move on. Deposit has an amount and a reply to, and we don't have to check any cases here, so we can immediately say reply to, bang, deposited. And then we have to switch the behavior, okay? How do we do that? Yeah, we just call apply again. Or we can just do account. And then we do balance plus amount. And that's it. Cool. And the same would be true for withdrawn. I will not type it, but just jump to the next step in my great sample solution. So it would look like this. Behavior same if it is insufficient balance, or account balance minus amount if it's okay. Does that make sense? All right. And for me, this looks a little clearer than in Akka untyped. And another benefit you get from defining actors like this in terms of behaviors is testability, because in Akka type test kit, there's a way to just test the behavior in isolation without the asynchrony and non-determinism, so without actors, without actual actors. You can, of course, also create actors like before and use test probes and stuff, but there's the behavior test kit that allows you to just test the behavior synchronously. And I think that's a huge advantage. All right, so there's a couple of more behaviors. If you need an actor context and a message, you use receive. If you need an early actor context, you use a setup. Setup is a little bit for these things which you would have done in the constructor of your actor, okay, untyped actor, or in the pre-start method. Receive partial if you want to ignore some unmatched messages, because here, let's say we comment that, we get a nice compiler warning that the match is not exhaustive, okay? So that's great. In most cases, sometimes you don't want to match on messages because you know this message cannot be sent, okay? If you have a state machine, for example, in some states, nobody will ever send a message of some type. And then receive partial is your friend. So you could do receive message partial, and then then the compiler would no longer complain. But then, of course, you could forget things. So I'm always a little bit, if I add the partial, I'm a little bit, is it necessary? Sometimes it's necessary. All right, stopped. Well, guess what behavior stopped will do? That's the way to stop an actor, or an actor to stop itself. In archetype, you no longer can stop arbitrary actors. So you can use context to stop a child actor, or you can just return stop behavior to stop this actor, and that's it. And there's also receive signal to just receive lifecycle signals. Okay. The actor context is, again, like in untyped, the power API. It has a lot of important methods. So two of them are spawn to create a child actor, and message adapter to ingest external messages. Oh, what does that mean? Okay, I will give you an example. So let's think about transfer. So we have two accounts, and we want to transfer money, right? And let me move on to the skeleton for the typed transfer. So here's transfer. What we are going to do, we create a child actor for an account and another one. We call the one from the other two. We use context.spawn. In order to get the context, we use behavior setup. So we have an early context. This is like our main actor. It has a seal trait command with not a single inhabitant. So you cannot send any messages to this guy, which is quite typical for the main actor, I would argue. And then we create a transfer actor, which we still have to implement, and we watch that. And the only thing our main actor does In its behavior, it's receiving the terminated signal for the transfer and then does behaviors stopped, which means the main actor stops, which means the whole actor system will terminate. Okay, and in Akka typed, in order to create an actor system, what you have to do is you have to pass it the root actor or the main actor, whatever you want to call it. You can no longer call actor of or spawn or some method on an actor system to create arbitrary many top-level actors. There's only one root actor. You pass the behavior into actor system will create it for you, and all the other actors you want to create have to be child actors of your main actor. Okay. I think I won't implement that, but just move on and show you how to implement a transfer could look like. So the first thing we do in the apply method here, we take an amount, that's the amount to be transferred. We have our from and two actors. From is an actor of withdraw, and two, one of deposit. We use the context to send the withdraw message to from. That makes sense, right? With the amount, and now this is interesting. Let me again go to the withdraw message. The withdraw message takes an actor f of withdraw reply. Okay, we need to provide an actor so that can receive a withdraw reply, like an insufficient balance or withdrawn. Our transfer actor here has its own sealed trait command. It cannot receive the withdraw reply. In Akka untyped, you could send anything to any actor. There it was really easy to implement request reply because any actor could receive the replies from another actor. It's not possible here. We can only receive in transfer our command subclasses. But the withdraw reply is from account and not from transfer. So therefore, we need this message adapter thingy. And that just adapts from the withdraw reply, which could either be an insufficient balance or withdrawn, to an internal message. So we have to more or less duplicate the messages as internal messages. Okay, so as they are commands, I call them handle insufficient balance and handle withdrawn and these things. So that is a little boilerplatey, I have to agree, but it's necessary for the type safety. So first we send the withdraw to the from, and then we define our behavior. So here we use withdraw partial, receive partial, to either handle the insufficient balance or the withdrawn, okay? We don't want to handle deposited because that cannot happen at that stage, right? The only responses we get from the from actor is either insufficient balance or withdrawn. In the first case, we abort, we stop. And the second case, we know the money has been taken away. We can now deposit it to the other guy. We send deposit to 2. And again, we have to do the message adapter thingy to get the deposited reply into handle deposited, which we will then handle, and then print transfer done and stop. Does that make sense? If you have questions, let me know. Okay, so let's just run it and see whether everything works as expected. We are transferring 50, so that should work. It says transfer done, which is great. And you can see that the program has terminated, so even receiving the signal seems to work properly. If we try to transfer too much, we should get the abort message. Okay, so that all looks pretty good. Okay, so if you want to migrate from untyped to typed, you have to keep in mind 2 or 3 important things. So first, you should use ADTs for the message protocol. So you have to define your seal trait command or call it message if you prefer that, or anything. So yeah, use an ADT so the compiler then can help you, telling you, okay, your match is not exhaustive. You have to add this or that command to your match. You have to replace the implicit sender with an explicit reply to address or actorref. And if you want to consume messages that are defined on some other actor, you need to use those message adapters. And that's essentially the tweaks you have to apply. What I really like about Akka typed is that it can completely coexist with the untyped. So there's only friendly competition amongst them. So if you import the various methods defined in this adapter package object, everything between untyped and typed will work. For example, you can use an untyped actorref where a typed actorref is expected, and vice versa. So you can send a message from a typed actor to an untyped actor, or an untyped actor can watch a typed actor, and vice versa. There's a small difference regarding supervision, which I will show you in a moment. So let's first take a look at this coexistence. So we can write an untyped transfer that uses these typed accounts. So what we have done here is we have written a typed transfer, okay? And let's just take a look at an untyped transfer. I call it mixed transfer here. Where is it? Where is it? Mixed. Okay, here's a transfer. And that is just a traditional class that extends actor. The parameters it gets are typed actorrefs. And then when we send this withdraw to the typed from, we include self as the reply to. And as you can see here, this underline means, okay, something's going on, some implicit conversions are going on, and that is because of this import second line or line 21, the adapter import. And you probably also can see it here. And that works exactly the same way like the typed account. It compiles, and I hope you believe that it also runs the same way. And I think this is really great. So it means you can start adding typed actors to your projects, to your Akka projects. You don't have to rewrite everything in a big bang, but you can start adding new actors as typed actors and get used to them and see what they are good for, what is not that good. If it's not that good, let the Akka team know. They're open for feedback. And this coexistence, I think, is a very, very important aspect. And actually, if you look at the Akka libraries, which are on top of Akka actor, like, for example, streams or HTTP or cluster or persistence, some of these have been ported to typed, but usually not complete. I mean, Akka persistence typed is a complete rewrite, whereas the various Akka cluster type modules just have a thin facade, a typed facade on top of the untyped. And that totally makes sense, because so the Akka team can or could slowly move to typed if they want to, under the hood for the implementation. Okay, so one more thing I would like to mention is supervision. And the difference to untyped is that in Akka typed, faulty actors are stopped by default, which means if there's an exception, the actor gets stopped. Do you know the default in Akka untyped? What's the default in Akka untyped? No. Yeah, in most cases it's restart, yeah. So there's a couple of exceptions which are treated in a special way, like if the exception occurs during initialization, for example, or if you don't handle the terminated, the actor will be stopped. But in most other, in most other cases, yeah, the actor gets restarted. In my personal experience, that is not a good default, and it looks like the Akka team has arrived at the same decision. So in most of my Akka projects, I use the supervisors, the stopping strategy. So Akka Untyped also has a stopping strategy, and I use that for most of my actors as the default. And yeah, it's the default in Akka type now. And if you want to change that, you can supervise a behavior. So what you do is you have a behavior and then you wrap it in behaviors.supervise. Okay, so it's a little different. It's not that you have to define a supervisor strategy at the level of the parent actor, but instead you define your behavior to be supervised in some way. And let's take a look at one more example. A calculator actor. So it's a huge actor for this small example, sorry for that. It's a calculator, you get add, subtract, multiply, divide, and divide is interesting. So as you probably can guess, if you send divide to this and n equals 0, you might get into trouble, right? And our program here, what does it do? So here we just create the calculator actor. Sorry, that's the behavior. We're creating it in the spawn method. Let's be precise, that's the behavior. We initialize it with 0, and then we send an add 42, because 42 is always a good value, and then we divide by 2, and then we try to get the value, okay? Let's see what happens if we run that little program. Okay, ooh, yeah, some exception has happened, like expected. We get an arithmetic exception by 0, and it looks like we don't get any value back, okay? And it says stopping because calculator terminated. Let's again look at the code. So when we receive the terminated signal, we get this, and yeah, the get value looks like it's not really gotten. So yeah, the actor has been stopped. That's the default, as I said. And now let's switch the whole thing a little bit. So instead of not supervising it, let's supervise it. So now we do behaviors.supervise. So we essentially wrap our calculator behavior in this supervise block. And in order to get back a real behavior, because that's just a supervise, we call the onFailure method. And here we provide an exception type. And then in this case, I decided to resume. So if we divide by 0, that should essentially just be ignored. Okay, let's see how this works. Whether we get our 42 out of it. Hooray, we get it. So that's how supervision works in Akka typed, and I personally really like that, because even when I was writing specialized supervisor strategies, not the stopping strategy, but real ones in Akka untyped, I never had the situation where I had to build a huge pattern match, like case foo exception do this, case bar exception do that. So you no longer have this decider function that goes from arbitrary throwables to some decisions like stop or restart, but instead you just provide one exception type and that's it. Of course you could go for throwable or exception, but yeah, usually in the code I've seen there's one particular type of exception that can occur, maybe a JDBC exception or whatever, and you want to deal with that. And yeah, that's what you can do in Akka typed. All right, so that was supervision, and that almost takes me to the end of my presentation. The current state of Akka typed is it is still an experimental module, or multiple experimental modules. So there's typed API or typed modules, jars available for Akka persistence, various cluster modules, distributed data, and even for streams. I think there's a very, very small addition just for the source and sync.actoref to be typed now. I recently gave a workshop on Monday and Tuesday, totally based on Akka typed, and you can build real-world systems completely on top of Akka typed. So everything is there you need. And the question is, what's next? So it's almost feature complete. Hopefully within the next releases, some smallish missing features are added. In my opinion, it's production ready. The API may change, okay, and that's what the meaning of experimental is. If you go to the documentation, which is really good, it says, okay, danger area, but that for me just means the API may change. That's okay for me. I don't think there will be too big changes. There have been big changes over the last half year, but nowadays I think there will only be smallish ones, hopefully. And yeah, please give it a try and give feedback. There's a couple of great discussions on the issue tracker if you're interested. So yeah, hopefully I could inspire you to give it a try. And thank you for your attention. I don't want to stand between you and lunch, but if there are questions, I'm happy to take a couple. Thank you. Who is the owner of the microphones? Because there's questions over there.
Hi. So in Akka typed, what happens to the actor event stream? So now you can publish something to the event stream and subscribe to events. What will happen to that?
That's a good question because I never use that thing. I wouldn't know why I should use it, but I guess it's still there because I told about this coexistence. So actually everything in Akka typed still runs on the untyped actor system under the hood. There is a typed system, but that uses the untyped under the hood. So I guess, and you can convert the untyped to typed and typed to untyped. So you can get access to the untyped actor system, which exposes your event stream, and you can just use it, I guess. But I didn't do that. Other questions? Over there.
Could you please just wait for the microphone so the others could listen as well? Thank you.
You mentioned that Akka Streams is also changing in the course of going to typed. What are the changes for Akka Streams concerning that?
I don't think there are big changes. So the changes I mentioned is the source and sync.actoref. These are methods that formally, of course, so there's the Akka Streams module, and there's the Akka Streams typed module. And in the Akka Streams typed, you get typed actorefs, okay? Other than that, Akka Streams is typed. So it's a nice fit, I would say. I think the map async will also be, so currently it's a little hard to do the ask pattern in Akka type because you need an implicit scheduler and everything. So there will be some helpers to make it a little bit nicer. More questions?
Here?
Okay.
Yeah, in Scala 3 they introduce union types, and now you do ADTs and sealed traits. Would it be more explicit if you use like a union type in the actoref type?
That looks pretty promising, yeah, but I don't think Akka would work on Dotty. Does Akka work on Dotty, guys? So the Akka team doesn't know, so we will probably have to wait a little bit and enforce the collaboration in that regard. Yeah, but that looks pretty promising, I would say. Yeah.
You told that your preference was using ADTs, and this is a bit different. It looks like.
Pardon?
You told us your preference was to use ADTs with the sealed trait, right?
Yes, exactly.
Instead of using an either or something like that.
So first of all, sometimes you have So if you have these diverging responses, sometimes you not only have 2, but 3 or 4 or whatever. That would not work with an either. And even if your protocol evolves over time and you start with 2, you might then add a 3, so then you're lost with an either. Then you have to do a larger refactoring. So therefore, I prefer ADTs. But of course, it is totally possible if you just have like A or B as a response, you could use either. Yeah, if you prefer that. I personally don't like it that much. Even options, I mean, they are just wrappers, and even an option could be expressed differently. But yeah, it's possible. I prefer, for various reasons, to not use either or options, but ADTs. It's more flexible. Okay, maybe one more question here. The first row.
Thank you. What happened with the patterns such as ask or pipe 2?
Okay, what happened with ask or pipe 2? So ask is there. It's more or less the same. It's a little different because of the reply to that now has to be fed into the message that is sent to the actor. So therefore, the ask operator not only takes a message, but instead takes a function from actor_f to message. If you think about it, it becomes obvious, but then if you forget about it, it looks weird again. So yeah, but ask is there. There's no pipe 2 at all. I think I asked Patrick, and he told me it's no longer necessary, which I don't totally understand. So yeah, pipe 2 is not there. You can just you can just work with the future and send it so you have to essentially do it your own. On complete handler and send to yourself, and please consume everything you take from the actor context before out. So consume everything inside the behavior of the actor and not asynchronously in this callback you give to onComplete. Okay, thanks. I'll be around if you have more questions at lunch or later today. I don't want to stand in your way, as I said, so enjoy your lunch and thanks for your attention.